This question from 1978 AP Physics B. AP Physics B used to be AP Physics 1 and 2 together, and in 2014 College Board split AP Physics B into AP Physics 1 and 2. And so this is the question on geometric optics. And in this question, they say an object 6 centimeters high is placed 30 centimeters from the concave mirror of focal length 10 centimeters as shown in the picture. On the diagram above, locate the image by tracing two ray diagrams beginning at point P and pass through the focal point F. Is the image real or virtual, and is it located on the left side or on the right side of the mirror? So for the ray diagram, again, we're following, like I have done previously a few questions with the ray diagrams and the lessons, we're following certain rules. The first one is going to be parallel to the axis and then through the focal point. And our focal point is going to be on the left side. So the ray would have to go it would scatter, or it would actually return to the focal point. So it would go this way. But your eye would imagine that the ray is coming from that side of the mirror. And then for the next one, you would have through the focal point, and then it would have to go parallel. So it goes parallel in this direction. And your eye would imagine that the ray is coming from that direction. So if you had an eye looking right here, so your eye would see the rays coming, the blue one from behind the mirror and the green one from behind the mirror. And your object would appear over here. The image of the object would appear over here. And the image would be real. It is inverted and could be projected on the screen. So this is where exactly the rays meet. It's not that the virtual rays meet, but the real rays meet. And it is located on the left side of the mirror, and it is inverted. For calculating the position of the image, I have to use the lens or mirror equation. So I have 1 over F is equal to 1 over DO plus 1 over DI. So they tell me that an object is 6 centimeters height, so that is given, and it is located, the distance to the image to the object is 30 centimeters, and the focal length is given 10 centimeters. So I have 1 over 10. Again, I could convert into meters, and my conversions would cancel 10 to the negative 2 from all of them, so I don't have to. And then I have 1 over the distance to the object. That one is given. So the distance to the object is given to be 30 centimeters. And plus 1 over the distance to the image. The common denominator is 30, so I'm gonna times every single term. So I have 1 term, 2 terms, 3 terms. I'm gonna times them all by 30. And when I times 1 over 10 by 30, I get 3. When I times 1 over 30 by 30, I get 1. And when I times 1 over di by 30, I get 30 over di. So from here, I see that the distance to the image is going to be 15 centimeters. And from this, you kind of see that if this distance was 30, then this distance is about half of it, so 15 centimeters. For the next one, they ask you to calculate the size of the image. So I have to do magnification formula. So magnification is equal to negative di over do. And then UDI is 15 and UDO is 30. So the magnification, and the negative sign is there, the magnification is negative 1/2 Negative tells me that the image is inverted, and again, if it is inverted, it is real. And 1/2 tells me the size of the object is 1/2. So the height of an image is 1/2 of the height of the original object, which would be -3 centimeters. And again, negative means that the image is inverted. And the last question, they ask you to indicate on the diagram above how the ray from point P to point Q is reflected, and if the aberrations are negligible. So all the rays that are reflected from point P would end up in where the image is appearing. So if you had a ray going this way, then it would be from the point P, it would be reflected back to where the point P would appear in the image. So here would be the direction of the ray. If you imagine the normal line or perpendicular to the surface, the gray line, so if this is perpendicular to the surface line, then the angle of incidence is equal to the angle of reflection. So this angle of incidence with the normal would be equal to the angle of reflection. That applies to all of the rays. Even if there was normal over here, it would be the same angle of incidence would be equal to angle of reflection. And that's all I have for this question. 1978 AP Physics B geometric optics problem. And thank you for watching, and I'll see you in the next video.